Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Dante Loretta, a professor in the university's Lunar and Planetary Laboratory and principal investigator of the OSIRIS-REx mission, which will return a sample of the asteroid Bennu on September 24th. Welcome, Dante.
Thanks, Tim. It's great to be here.
Dante, can you describe what will actually happen on that day?
On September 24th, after a 7-year journey, the OSIRIS-REx spacecraft will return to the vicinity of the Earth. About 4 hours before hitting the top of the atmosphere, it will spin up and release a sample return capsule, which is about 65 inches across. That capsule will hit the top of the atmosphere at a blistering 27,000 miles per hour. Fortunately, it has a heat shield, which absorbs most of that energy. It will reach free fall, deploy a parachute, and safely deliver samples of near-Earth asteroid Bennu to our waiting hands.
Have successful returns been done at that speed before?
Yes and no. So there has been multiple attempts to return samples from deep space objects. The most famous, of course, is the Apollo program of NASA in the late 1960s and 1970s. More recently in NASA history, there have been 2 robotic sample return missions. There was a mission called Genesis, which launched with a bunch of high-purity plates to collect ions from the solar wind. And there was a mission called Stardust, which collected dust particles from the coma or the environment surrounding a comet. Genesis actually had a hard landing, a failure to deploy its parachute. And Stardust, which worked perfectly, and the parachute deployed, and the sample was successfully delivered to Johnson Space Center in Houston, Texas.
How long will it take you to get to the samples once it comes down?
The recovery team will be waiting just outside what we call the landing ellipse. So we're coming into a region of the Utah desert that's controlled by the United States Department of Defense called the Utah Test and Training Range. And we have an ellipse, an area based on winds and minor details about how it flies through the atmosphere of where that capsule will land. We'll be stationed, a team of us, in 4 helicopters just outside of that ellipse. And the timeline will really depend on the weather conditions that are out there. Were we able to track the capsule, and do we know exactly where it is on the ground? In the nominal, what we call green light timeline, we should be there well within an hour of the capsule hitting the ground.
And then what happens to the samples?
So the first thing we do is recover that capsule, and we get it into a clean room, and we've set up a temporary version of that in one of the hangars at the Michael Army Airfield, which is part of the test range out there. And immediately we'll get that heat shield off, we'll get the back shell off, any batteries and things that aren't really necessary will be sequestered in separate containers. And then the science canister, which is the aluminum housing in the interior of the capsule where the sample is, that'll get bagged and put under a dry nitrogen gas purge, which is the environment that those samples will see throughout their time in NASA's possession. So the next morning on Monday, September 25th, weather permitting and recovery nominal, we will fly the sample from Utah to Houston, Texas, and deliver it to the Johnson Space Center.
And at what point will it start going out to scientists?
We hope, and it'll depend on the nature of the sample, but we hope that we get material within 1 day of opening the capsule, especially because when we stowed the sample, we were leaking material. It was slipping out of the collector. We expect that there might be dust adhering surfaces as soon as we get the canister open. And one of the first activities is just to do a sweep of that dust. We have Professor Tom Zaga here from the University of Arizona and Dr. Lindsay Keller at NASA Johnson Space Center leading a team of what I call quick look analysts. So literally day 1, they'll take the dust particles. They have electron microscopes and other great instruments right there at NASA. We should know a general idea of at least what the fine particles are made of within a day or 2.
And of course, how long scientists will be analyzing it? Well, it's been a long time since the Apollo program, and we're still analyzing those, so these will be around a while.
That's right. As you well know, Tim, being a fellow cosmochemist, right? Sample return is the gift that just keeps on giving. So we have a very ambitious 2-year program based on the mission contract to perform the first level of analyses. But I know it's going to be a complicated sample with a lot of interesting scientific directions to pursue. I expect to be working on it for the rest of my life, and I expect students and future researchers to be working on it well after I've moved on.
Good luck on September 24th.
Thank you, Tim.
Our guest today has been Dante Loretta, Principal Investigator for the OSIRIS-REx Asteroid Sample Return Mission. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.